Question number 7, last question on the notes. Okay, so again, using your calculator, picture, look at a picture. What does the picture look like? That's the first thing. Okay, so use your calculator to get a picture and sketch that picture. Okay? Because they don't give us a graph for this one. So you're going to use your calculator to come up with a graph, a picture. Okay, so this one is y equals x cubed. So x to the third power. And then x equals y squared minus 2. Okay, so I'm going to go over the templates. Y, so for y, remember, push alpha. Alpha 3. Alpha 3 is your y. So y squared minus 2. Go to graph. And the graph, the image they give me is kind of off, so I'm going to use navigate. Okay, so I'm going to go up to navigate and then kind of get a centered picture of it. So I'm going to scroll over, and there it is right there. Plus, now let's go minus. So there's my picture there. Okay, so I'm going to sketch that picture as best I can. Okay. So you sketch that in your notes as best as you can. Yep. Okay. So while you're doing that, the enclosed area, sometimes it's called enclosed area, sometimes it's called bounded area. Yeah, it's this area here, right? In between, it's blue and red on mine, probably on yours too, on your calculator. All right, this is the area here. Okay, so we'll call it R. So again, I could do this two ways. I could do it with respect to X and with respect to Y. Sometimes that's what they do. So I've seen this on FRQs, free response. They'll give you a question like this, and then they'll ask you to solve it two ways. They'll ask you to solve it with respect to X. That's the guy we did for 1 through 5. And then they'll ask you, do the same problem with respect to Y. Okay? So sometimes they'll have you do it two ways just so that they can see if you know how to do both ways. Okay? Okay, so let's set up, since we're doing with respect to Y, that's the only one we're going to do. So I need R. Okay, so now we have right curve minus left curve. So it looks like the red is on the right of the green. So I'm focused just on the green. Just on the green, right? The red is on the right, the blue is on the left. And from my calculator, the red was y equals x cubed. And the blue was x equals y squared minus 2. So that's x cubed minus, and then the left is y squared minus 2 dy. there an issue here anywhere?
The x squared.
Say it again?
I mean the x squared and y squared.
Yeah, what were you saying, Isaac?
There's an x with respect to y.
Yeah, you can only have one letter. And since it's with respect to y, this guy here is wrong. I need to write it with respect to y. That's with respect to x, right? This guy over here. If you didn't know, you would find out when you tried to put this in your calculator. Your calculator would have a fit because it doesn't recognize these things. It needs both of these guys to be the same. So since it's with respect to y, since it's a dy, I only want y's in here. So this guy over here, y equals x cubed, I need it to say x equals. Okay, it's not a big deal. It's not even that hard necessarily, but it is important. Okay, so how do I do that? You just solve it for y. So it's right now it's
Y to the 1/3 power.
y. Right now it's that, right? Solve it for x. How do I get x by itself?
Cube root it.
Cube root it, right? 1/3 power. Yep, just like you said, 1/3 power. Cube root it or take it to the 1/3 power. Either way, you don't have to do plus or minus for cube roots. You just have to do plus or minus for even roots, square roots, fourth roots, sixth roots. So there you go there. This guy is the same as this guy here. One is just with respect to y, one is with respect to x. So that guy is the guy I'm going to put first. So x cubed is the same thing as cube root of y. Okay, that was another big thing.
It would have changed the graph. Like the graph would still be the same.
Would it change the graph? It's a good question. We could check it out. We'll check it out later, yeah. Yeah, I could check it out later to see if it would. I don't think it would, but... okay, so now bounds. We don't want left and right bounds. We want top and bottom bounds, right? Top bounds and bottom bounds, and we don't want x values. We want y values. Okay? So, the bounds are where the green ends, top and bottom wise. I see that being here and here, right? There and there. So now I got to go find out what those points are. Go to your calculator, figure out where those points are.
1.2 and 1.7885.
So yeah, yeah. I got something similar, yeah. So go, oops, no, I don't want to do that. So yeah, so use your calculator to figure out where they intersect. So for the top guy, verify I'm right. I got 1.215, comma, 1.793.
Yeah.
And for the bottom guy, I got -1, -1.
For the top, you got 1.793.
1.793 for y. Let me double check. Yeah, again, this is what I got last year, so we've already seen one where it was wrong, so let me double check. Let me double check. Back, calculate, find. No, not find. Was it find? No, it should be find, right?
Yeah.
Why is there no intersection for that one? Let me try this one.
There's.
Is there one for you guys?
If you
No.
click on it and then you go down to find, and then you go down, all the way down to integral,
Yeah.
there's like a little line that pops up that'll show you if you go.
Oh, okay. So it's just kind of a workaround.
Yeah.
So let's see. So then we kind of go here. So the lower bound is -1. And then the upper bound is 1.2. Yeah, 1.2. Wait.
I think it's an X though, right?
Yeah, it's an X. So how do we do
Yeah,
one?
so if you just go to the graph, you can move the point
Oh,
along
do you use a
inside the
little-
intersection.
Use a little cursor.
Uh-huh.
Let's see. 1 second. Flores. Okay, so yeah, how did I get that closer last year? I don't remember how I got that closer last year. But, so yeah, so it's 1 point. So, let's see, I don't know why it's doing that.
1.2148 for X.
Yeah, but I don't care about X, I want Y, because this is the Y values. Yeah,
Closest one I have is 1.791.
Yes.
yeah, okay, that's fine.
I
That's,
just
that's pretty
Googled
close. I had 1.793, so yeah,
Okay.
that's more than okay.
Yeah, you just have to like zoom in super close because it doesn't
Okay.
find the.
Yeah, the intersection. I don't know why it doesn't do intersection for those. It's weird. Okay, so here we go. Okay, so we got -1, because -1 was the first Y value. And then we got positive 1.791, you guys said? That works.
Yeah.
Hard part's done.
But
So-
what did it say on there?
It's on my notes, it said 1.793.
Oh yeah, it would be 1.793 because if you round it up.
Oh,
it's
okay, gotcha, okay.
1.793.
Okay. Okay. So do that in your calculator. Verify that we got this, 4.215. Okay.
If we were doing the test,
Yes.
but we got the top bound wrong, would it change the?
It would probably change a little bit, but
Wouldn't-
I look at your setup, so that's a great question. So I had one student, because I'm finishing grading your tests, and I think there was one student, maybe two, whose setup was perfect, but their answer was totally off. So I grade setup as opposed to answer. So that student, I gave full credit because their setup was right. It must have been something they put into the calculator wrong. It must have been a user error on the calculator. So if you have this setup, even if you're off like a little bit there and your number is off, I'd still give you full credit. I'll still give you full credit on a multiple choice, on a free response. Multiple choice, I can't because it's either, because you got to choose one. But that's a great question. They grade setup, not necessarily answer. Okay, yeah, because I can't remember. When I hand them back, I'll probably hand them back on Monday. When I give them back to you guys on Monday, I'll show you that, yeah, I think it was one or two students. I don't know what happened. Maybe they just plugged it into the calculator wrong, but their setup was perfect. It was exactly like what it should be, but the answer was way off. And so that student, I'm just like, it was a calculator issue. It wasn't that they didn't know their calculus. They knew their calculus. You can't do the setup correct without knowing your calculus, right? It was a calculator thing. So yeah, that's a great question. So setup, I grade. Answer, I'm a little lenient on. I'm lenient on it because sometimes something happens, especially if it's a calculator question. Because I'm not grading you on the calculator, I'm grading you on the calculus, okay? So yeah, good question. Yeah, always better to show me setup than answer, because sometimes you just give me an answer. I can give you a point for the answer, but then I can't give you the other 2 points for the setup because you didn't have a setup. Okay? So yeah. Okay.